Okay, so we're going to start today's assignment with number 7. So we were given the equation y equals 5x minus 2. Now, in order to do this, we're going to take whatever our x input is, or our x value, we're going to plug that into the equation. So if we zoom in here, so our first x is 0. So we're going to have 0 plugged in for x. So we're going to have y equals 5 times 0 minus 2, right? And that's going to give us 0 and then minus 2, which would just be negative 2. All right, so our first fill in the blank is going to be minus 2. Right, our second, right, is going to be y equals 5 times 3, right? Our x value is 3, so 5 times 3 minus 2, which is going to be the same as 15 minus 2. 15 minus 2, which is 13. So we're going to get to plug in a 13 right here. And then finally we have minus 9, so y equals 5x, which is negative 9. So 5 times negative 9 minus 2, right? And 5 times negative 9 is just the opposite, or the negative of 5 times 9, which is 45. So negative 45, minus 2, which is negative 47. So let's see if we can write this. Negative 47, right in that blank. There we go. Perfect. Moving on from number 7, we are number 9. Okay, so it looks like step 1 is just a box. Step 2 is a box plus 1 to the left, 1 above, and 1 to the right. Step 3 is that same, right, single box in the middle, but it's 2 to the left, 2 above, 2 to the right. So if we want to draw the next 2 in this sequence, we probably want to go for step 4 here. Let's draw our box, and then let's go 3 above it. 1, oh, not trying to draw there. Trying to move a little bit. There we go. We'll go 3 above it. So 1, 2, 3 above it, 3 to the left of it, 1, 2, and 3, and then 3 to the right. 1, 2, and 3. Okay. And now we're going to step 5. We'll do it in a different color. That's fine. All right. Oh, looks like we're drawing twice as wide here. There we go. Let's make that thinner. And we will erase that and go again. Okay. So we have step 5, right, where we're going to have the center box. But now we're going to need to go up. If we went up 1 on step 2, up 2 on step 3, up 3 on step 4, we need to go up 4 from here. So 1, 2, 3, and that's 4 up. Then 4 to the right, 1, 2, 3, 4, and to the left, 1, 2, 3, 4. Okay, so that is our step 5. So it does look a little bit bigger each time, so that's good. It is getting bigger with each step. So that's draw steps 4 and 5. So we did that. All right, Dan explained that the middle tower is always the same number as the step number. He also pointed out that the 2 arms on each side of the tower contain 1 less block than the step number. Okay, so we're going to break this into 2 parts. First, we'll do it in green. The middle tower is always the same as the step number. That's like our first part. And then it says he also pointed out, okay, that the 2 arms contain 1 less block than the step number. All right, so that is our second piece. So create an equation that fits Dan's way of seeing this relationship. So Dan saw it in 2 parts, the middle tower part and then the 2 arms part. So his equation, right, or an equation that models or fits his way of seeing this is that our number of tiles, or our number of blocks, let's call it, so blocks B, is equal to the let's see, it's the middle tower has the same number of blocks as the step number. So if the step number is n, we're going to say that the blocks is equal to n for the middle tower, plus, and there's going to be some purple portion, right? 2 arms. 2 arms means it's going to be 2 of whatever the size of an arm is. And it says that each arm is 1 less than the step number. So 2 times 1 less than the step number. Well, the step number is n. So 1 less than that would be n minus 1. So this would be an equation that fits Dan's way of seeing the relationship, right? The number of blocks is equal to the step number plus 2 times the step number minus 1. All right, that's number 10. Let's move on. Where are we going next? 13 and 14. All right. So we get a little bit of function notation. Basically, we are given that the function of n, right, f of n is 8n minus 3. All right, 8n minus 3. We're going to make this purple. That's fine. 8n minus 3. Oop, went too far. Let's try that again. 8n minus 3. And then g of n, right, so our other function g of n is 3n minus 10. All right, so we want to evaluate the following functions with indicated values. Okay, so for 13, f of 1. All right, so we got to be looking at f, so let's do this in purple because f is purple. F of 1, so we're going to take our function, our 8n minus 3, and we're going to write that, but we're, all right. But we're going to go 8, and then we're going to plug in that 1 where we had seen n, and then minus 3. All right, so this is saying our order of operations, right? We have 8 times 1, which is just 8. And then we subtract 3, and we know that 8 minus 3 is 5. All right, so 5, and we are done with that. And on to number 14, g of 0. All right, so for g of 0, we're going to do this one in green because we labeled our g function in green. So we have 3n minus 10. All right, so 3 times whatever our n is, in this case our n is 0, minus 10. All right, so when we do this, right, we start out with 3 times 0, which is just 0, and then we subtract 10, minus 10. Right, 0 minus 10, that's just negative 10. So that is our answer for number 14, is just 10. Oop. All right, and let's keep on moving. Here we go. All right, we're into the goes now. Write each expression using an exponent. All right, using exponents. So we know exponents are repeated multiplication. So we gotta be sure we're gonna be drawing here. So repeated multiplication. All right, so we have 7 times 7 times 7 times 7. That's 4 sevens, 4 of them multiplied together, right? We have 1, 2, 3, 4. That's 4 of them. So we're gonna have 7 to the 4th. Right, our exponent is that little 4 because there are 4 of the 7s. All right, so we're jumping down to 19. 1/5 times 1/5. Now this is harder because it's a fraction, but it's going to be the same as number 17, where we see 1/5 here once and 1/5 here again twice. So our base is going to be 1/5. And the exponent, the number of times it got repeated, multiplied by itself, right, is 1 here, 1 there, 1, 2. That's 2 of them. So it's 1/5 squared. Now, something tricky here is that order of operations says we do the exponent first. And since a fraction could be thought of as division, we're actually going to want to put parentheses here just to make sure that we are talking about 1/5 squared instead of 1 squared divided by 5. So whenever we have fractions with exponents, it's good to put the fraction in parentheses. All right, let's move on down for 21. All right, so on the last one, we had expanded form and we were going to exponents. Now we see exponents, right, in this expression, and we need to make it expanded form. So if we have 5 to the 4th, our expanded form would just be 5, which is our base, repeatedly multiplied by itself 4 times. So 5 times 5, that's 2, times 5 is 3, times 5, and that's 4 of them. All right, so that's our expanded form. 5 times 5 times 5 times 5 is 5 to the 4th. And then value of the expression, the way that we would solve this is, well, there are 2 ways. One, we could just plug it into our calculator. But assuming we don't want to just plug it into our calculator, right, what we're going to do is actually go step by step. So the first 5 times 5, right, first we're going to rewrite our equation over here, or expression rather, right? This first portion, 5 times 5, is just 25. All right, and then we'll bring the rest of it down. Times 5 times 5. Right, then we'll go change colors. 25 times 5 is 125. Like if you had 5 quarters, you would have $1.25. So 125. And then still that times 5 comes down. And then finally, we're only left with 125 times 5, which we could do the big multiplication out. We could do that. Let's say we wanted to do this in orange. That's fine. We could do this in orange, right, over here. 125 times 5. Right, we could do this. 5 times 5 is 25. Carry the 2, and we bring a 5 down here. 5 times 2 is 10, but we have to add the 2, so that becomes 12. And then we have 5 times 1, which is 5, plus another 1 is 6. 625. All right, so our answer here is 625. That is the evaluation of the expression 5 to the 4th. So 5 to the 4th equals 625. And our last step, we have evaluate the expression 6n squared for n equals 3. All right, so 6n squared for n equals 3. So right off the bat, we see that n equals 3. So we're actually going to plug this 3 in where we see n. All right, so this is going to become, oop, the lights just went out on me. Hang on. All right, there we go. As I'm making this video, the lights in this room are motion activated, and I guess I wasn't moving around enough, so I will do that some more. All right, 6n squared, so we got to write that, but we're plugging the 3 in for n, so we have 6, and then 3 squared. All right, and we want to figure out what that is. 6 times 3 squared. Well, our order of operations, right, PEMDAS, as we may have learned, right, says that parentheses come first, right? All right, so this 3 is definitely a 3, so parentheses first. Then it says we do exponents, right? Our exponent, right, is here. So before we do 6 times 3, we actually have to do 3 squared, right? So what is 3 squared? Let's think about that. 3 squared, what is this, right? Well, 3 squared is just 3 times 3, right? It's 3, our base, multiplied by itself, a total of 2 times, right? So 2 of them multiplied together. So we have 3 times 3. So we know that 3 times 3 is 9. So we're going to plug that back in. All right, so this becomes 6 times 9. And we could do that out, but we might know that 6 times 9 is 54. Right? And we are done with our last problem.